Okay, so our first example, I'm going to have a sailboat again. In this case, I'm going to have the sailboat here, and it's right there, and there should be a hull, or a keel, excuse me, down there. There's some water. We don't care about the keel because it's going to be a one-dimensional problem. I've got my wind pushing this way, right, and then I've got the water resistance, should go up a little bit more, coming back. Okay, and the boat's moving at 5 meters per second. The wind is causing a 2000 Newton force. Water resistance is a 1500 Newton force. So we want to, these are unbalanced, so this is going to tend to speed this up. So I want to figure out how much, or what the acceleration is, how much it's speeding up per second. Okay, so that's going to be A is equal to 1 over m times the sum of the forces that we did previously. So we've got the wind going forward, right? Wind's going to the right, minus the hull resistance, the drag, going backwards. Okay, so let's see. We had a mass that's 1,000 kilograms. We've got wind, which is 2,000 newtons, minus 1,500 newtons for the drag. Okay, so that means we end up with 1 over 1,000 kilograms times 2,000 minus 1,500, which is 500 newtons, which is equal to 500 over 1,000 is 1/2 Newton per kilogram. A Newton is kilograms meters per second squared, which is 1/2 meters per second squared. So a Newton is what we're measuring this in. Meters per second squared is an acceleration, so we are good. Okay, so what we did there was we identified the forces first, right? After we identified the forces, we could put them into this equation for the acceleration. This is basically Newton's second law. When we identified the forces, we identified their direction, so that's where the minus sign comes from, is the drag is pulling backwards, whereas the wind is pushing forwards. Then we made our substitutions, right? We said, okay, well, we've got 1,000 kilograms for the mass. We've got 2,000 newtons and 1,500 newtons here. And then we just did the math. Subtract, divide, and we got A equals 1/2 meters per second squared. That's our acceleration from that wind, that gust. So in the example for the next section, what we'll do is we'll look at what that means for the for a particular time. So we're going to choose how long the gust is actually active. And when we choose how long the gust is active, we'll be able to decide how much faster it's moving. So we'll find how much faster this boat is moving in the next example. But before that, we'll talk a little bit about what acceleration means in terms of velocities. Bye now.